Imagine a flat sheet of steel becoming the body of a car, a skyscraper wall, or even an aircraft wing. But here's what nobody tells you. That incredible journey begins deep beneath Earth's surface, long before factories ever start working. Every perfectly flat panel survives crushing pressure, scorching heat, and machines powerful enough to shake entire factory buildings. You hear thunderous impacts, smell hot metal, and watch glowing sparks explode as precision replaces raw strength. Most people never think about this. One tiny flaw can ruin an entire vehicle worth tens of thousands of dollars. So how do manufacturers create panels thinner than a coin, yet strong enough to protect lives every single day? The answer combines geology, chemistry, robotics, and engineering on a scale few people ever witness firsthand. Today, we're stepping inside one of the world's most advanced sheet metal factories from beginning to astonishing end. Think about this. Thousands of tons of steel arrive daily. Yet every finished panel measures with astonishing microscopic precision. Some production lines never stop, operating 24 hours a day, producing thousands of perfectly identical panels every hour. Yet none of it matters unless the raw materials begin with extraordinary purity hidden inside ordinary-looking rocks. What happens next surprised even experienced engineers, because the journey starts thousands of kilometers away from every factory. Our first stop isn't a factory at all. It's the massive mines where every future sheet metal panel truly begins. Our journey begins in Australia, Brazil, Canada, and Sweden, where rich iron ore deposits supply many of the world's largest steelmakers. Some mines produce or containing more than 65% iron, reducing waste and improving steel quality before refining even begins. Gigantic rotary drills bore holes nearly 20 meters deep before carefully timed explosions break millions of tons of solid rock. When explosives ignite, the ground trembles, roaring echoes fill the valley, and mountains briefly disappear behind enormous clouds of dust. Think about this. One haul truck carries nearly 400 tons, equal to the weight of more than 200 cars. Powerful crushers reduce house-sized boulders into fist-sized rocks, preparing the material for efficient grinding and magnetic separation. Next, rotating mills grind the ore into powder finer than beach sand, unlocking valuable iron from surrounding minerals. Powerful magnetic separators pull iron particles away from unwanted rock, leaving behind a much richer concentrate ready for steelmaking. The concentrated powder mixes with water and binders before rolling into marble-sized pellets, each designed for efficient furnace performance. These pellets harden inside furnaces reaching nearly 1,300 degrees Celsius, gaining strength for their next demanding journey. But iron ore alone cannot create premium sheet steel. Another remarkable ingredient quietly transforms everything inside the blast. That ingredient starts as coal, heated without oxygen above 1,000 degrees Celsius, until almost pure carbon remains as coke. Limestone completes the recipe, capturing unwanted impurities and forming molten slag that floats safely above the liquid iron. Together, iron ore, coke, and limestone travel thousands of kilometers by train and ship before reaching modern steel plants. What happens after these raw materials enter the furnace creates temperatures hotter than volcanic lava, and that's where our story truly ignites. Inside the blast furnace, temperatures climb beyond 1,500 degrees Celsius, melting iron into a glowing river of liquid metal. Superheated air blasts upward at nearly 1,200 degrees Celsius, feeding powerful chemical reactions that remove oxygen from the ore. Every few hours, workers tap the furnace, releasing nearly 300 tons of molten iron in one spectacular pour. The brilliant orange stream shines brighter than the sun, forcing every nearby worker to wear specialized heat-resistant protection. But here's where ordinary iron transforms into premium steel through one astonishing burst of controlled oxygen. Pure oxygen enters at supersonic speed, burning away excess carbon while temperatures briefly approach 1,700 degrees Celsius. Think about this. The entire steelmaking reaction finishes in barely 20 minutes, faster than watching a television episode. Laboratory technicians immediately test samples, adjusting chemistry until carbon, manganese, and silicon reach exact specifications. Next, continuous casting begins as molten steel flows into water-cooled copper molds, forming an endless glowing slab. Powerful sprays cool the surface instantly while the core remains scorching hot, preventing dangerous cracks from forming. Enormous rollers squeeze the slab repeatedly, reducing its thickness while stretching it into astonishing lengths exceeding 100 meters. The steel races between rollers at nearly 20 meters per second, roaring louder than a jet during takeoff. After cooling, cold rolling presses the steel again under enormous pressure, creating the smooth finish demanded by modern industries. Powerful hydraulic presses exert thousands of tons of force, shaping flat sheets into complex automotive body panels within seconds. What happens after stamping determines whether every panel becomes flawless or ends as expensive recycled scrap waiting for another chance. The moment stamping ends, intelligent inspection systems begin searching for flaws smaller than the width of a human hair. High-speed cameras capture thousands of images every second, revealing dents, scratches, wrinkles, and invisible surface imperfections instantly. Laser scanners measure every curve within fractions of a millimeter, comparing each panel against its original digital engineering model. Most premium factories hold dimensional tolerances within plus or minus 1/10 of a millimeter across large automotive panels. Think about this. A single unnoticed wrinkle could create wind noise, paint defects, or assembly problems months later. Powerful robotic arms stack flawless panels with incredible precision, preventing even the smallest scratch during transport inside the factory. But human experts still perform the final visual inspection because experienced eyes notice details machines occasionally miss. Workers glide gloved fingertips across polished steel, feeling subtle imperfections too delicate for cameras to recognize consistently. Panels also survive demanding bend tests, coating checks, corrosion chambers, and repeated impact evaluations before customers ever see them. Many manufacturers follow internationally recognized quality standards, ensuring every shipment meets demanding customer specifications before leaving the plant. Even with advanced automation, only a tiny percentage of panels fail inspection, protecting safety, reliability, and customer confidence every day. But here's what nobody tells you. The worldwide story behind sheet metal panels is even more astonishing than the factory itself.